Hey guys, I wanted to go over this quiz with you so we can make sure we're all okay with this. Alrighty here. So, first things first. Number one, what does the else part of an if statement do? So if this test is true right here, we're going to say great job, and we won't do anything else. We'll come down to the code after that. We will not do the else. If this test fails, if the score is, say, 50, this fails, we do the else. So the else is what we do when this test fails. Okay, the else is what we do when this test fails. You're never going to do this and this. No way. If the test is true, you do this and you skip over the else. If this test here fails, we don't do great job, we do the else. The else handles the situation when this test fails. Okay, number two. In the code with the grade here, if the first test was true, if score is less than 60, the code continued to check all the other if statements, and the answer is false. If this test is true, if I got a 58, it's going to go ahead and print grade is F, and it will skip out all this. It will not even do any of those things. It skips out. So if this test is true, print grade F, and then it will not do anything else associated with this else, elif, elif. Okay, number three, what does this mean? In a real computer program, if you said byte num1, byte is a data type, and num1 is the name of the storage area in RAM, the name of the variable. Byte means that the variable in RAM is 1 byte big. It can only hold a whole number, and the values are between -128 to 0 to 127. That's it. So data type followed by a variable name creates a storage area in RAM, and the data type tells the computer what num1 can hold. In this case, a whole number between -128 and 127. Number four, 31 base 10 to hex. Okay, so I have, remember down here I have 116, I have 116, and I have 15 ones left. That's F1s. 31 base 10 is 1F base 16. Okay, how is lowercase d stored if you have a character in RAM? So if you had a character like char, letter, right? Letter is a variable of type char. It's 1 byte big. It can only hold a character on your keyboard. Lowercase d is 64, 32, and a 4. So 100. Remember, 65 is capital A, 66 capital B, 97 lowercase a, 98 lowercase b, 100 would be lowercase d, and 48 would be character 0, 49 character 1. So lowercase d is 64, 32, and a 4. All right, number 6, how is -12 stored as a byte? Well, first thing I do is I find +12. Right here, I turn on the 4 byte and I turn on the 8 byte. That's +12, and then using the shortcut, I go up to and including the first bit that's on. I start at the right side, so 001, I keep them the same, 001, and now I flip them. So this 1 right here becomes this 0, and all the rest of these zeros become 1s, and this is -12. All right, 7. What's the output of the following? So let's suppose x is 45, y is 80. It says, while 45 is less than 47, and 80 is less than 100. Well, both these are true, so I'm in. X is now 46, and y is now 81. I print 46 and 81. Right here, I print them out. Now I loop back. What's x? It's 46. Is 46 less than 47? Yeah. Is 81 less than 100? Yeah. Add 1 to x, so now x becomes 47. Add 1 to y becomes 82. Print 47 and 82. Loop back. Is 47 less than 47? No. And that's an and, so this would have to be true as well as this to continue. No, this test fails. 47 is not less than 47. We're done. This is the last thing that you'd see displayed on the screen. Number 8, what does compression do? Makes the file smaller to either store on our disk, or smaller to send it over the internet and it gets there faster. So compression makes files smaller. Number 9, 2 types of encryption. Symmetric, which is one key, very fast, handles large amounts of data. Asymmetric, which is very slow, 2 keys, and key exchange is not a problem. For symmetric, key exchange is a problem. For asymmetric, it's not, because they have 2 keys, a public and a private. The best one to send large volumes of data is symmetric. And, okay, which one should you use? I would say you should use asymmetric to send the key for the symmetric algorithm, asymmetric to send that key over to the other side, and use symmetric to send all the data. And that's how I would run that. Okay, hope this helps. When you're done, just make sure your name is on this quiz and put it up on my desk. Number 1, let's go back here real quick. Number 1 is worth 1 point. Number 2 is worth 1 point. Number 3 is worth 1 point. Number 4 is worth 1 point. Number 5 is 1 point. Number 6 is 1 point. Number 7 is worth 1 point. Number 8 is worth 1 point. And number 9 is worth 2 points. Score it and just put it up on my desk. No big deal. If you didn't do well, don't worry about it. We'll work on it again when I get back.